How's it going? My name is Key Clark, and thank you for coming back for another episode of OpenPair. In this specific playlist, we're looking at the Go programming language, and this is episode 8, where we'll be diving deeper into the linked list iceberg. If you joined me last time, I was working on a little exploratory project where I just basically was coding up different files that have various explorations of linked lists, starting off with a basic linked list and then working up towards more advanced versions of a linked list with different features and capabilities. And so this stream is going to pick back up where I left off in the last one and then hopefully finish out these exercises so that I'll be able to move forward with this new knowledge. So we're going to start off this stream firstly by reviewing the repo that I've been working on, also the general concept of a linked list for anyone who's not seen this stream or who doesn't know what a linked list is. And then I'll be jumping back into the actual work of finishing out my remaining tasks for this. So if you are new to this stream, I am a teacher in real life. I actually teach software engineering, mostly Node, React, JavaScript, Express, stuff like that. But I've always wanted to learn a language that has more like lower level capabilities, faster, something that just allows me to explore different types of problems. And that's why I've chosen GoLang. So although I am a teacher, this language is something that I'm still learning. And this whole channel, the premise of it is that I don't have to be an expert. I'm just sharing my learning journey with you. So follow me on this adventure and let's jump back into this project. Okay, so this project has an accompanying repo, as do all of the OpenPair GoLang streams. If you go down to the description down below, you'll see that there's a link to my GitHub where you can see this project in its current state. And then by the time I finish this stream, I will have committed and pushed up the remaining code. So if you want to, you could actually go to that repo and see exactly the results of what I've worked on here. And with this project, I have 3 basic files here. These are set up as separate packages that all feed into this main function here, so that when I run my program, I can just uncomment out any of these functions here and then see my code run. In each of these files here are going to be like different versions of a linked list. I've already completed the basic linked list, which only has the ability through a method to add a new node at the end. And I'm working on the advanced linked list that can add a new node at the end, but also can add a new node at the beginning, as well as reverse. And then, as you'll see later on in this stream, we'll be learning how to delete a node as well. So I'm learning this as I go. I don't know that I could explain every single thing, but that's a part of the fun in this for me. I kind of think of this like a game. Every time I face an obstacle or challenge, I think of it like a level in a game. I don't take myself too seriously and I allow myself to make mistakes, and it's okay to not know what you're doing. Like with any game, the more you try, the better you'll get. That's my philosophy. So if you're new to this and don't know what a linked list is, let me help you understand. So I made this diagram in the last stream, and I think this is a great explanation. So a linked list is a linear data structure in which the elements are not stored in contiguous memory locations. So what this first sentence means is that normally when you make an array in GoLang, you have to basically signify the size of that array, right? So if you have 4 objects in your array, from the moment you initialize that array, you have to tell your computer programming language to make an array size of 4 so that it will go and allocate that memory for that use. And arrays are data structures that cannot be expanded beyond what they're initialized as. And arrays can be incredibly fast because things tend to live next to each other in physical memory, but also because you're having to determine the size of an array at the onset, it's not very flexible. And so that's where linked lists come in as a comparison. So to compare, a linked list is also a collection of data, but this data does not need to live in contiguous memory, meaning that as this data structure is created, the information, the data that it holds can be anywhere in memory. The way that you keep track of all of these items in this collection is by having pointers and references from one thing to the next. So the elements in a linked list are linked using pointers as shown in the image. Um, a great resource for learning about this that I found is Geeks for Geeks. In fact, let me go ahead and pull this up for you. So if you go to this website, geeksforgeeks.com, they actually have a diagram that is pretty close to the one that I made. In fact, this is what inspired me to make my graphic. So if you look at the URL bar here, it's just geeksforgeeks.org/data structure/linked list. In fact, if you Google this, it'll be one of the first results that'll show up for you. So if you want to know more about this, I would recommend going to their website. They have all of these great sub pages that just dive super deep into what a linked list is, the different variations of one, and then also what can you do with it. What kind of problems can you solve with this knowledge, with this data structure? So I'm going to be taking this linked list today and just kind of building on what I did yesterday. And the basic point of the linked list here is that if you have these nodes here, these nodes represent individual members of this list. Each member, a node, can have some data, and it also has a reference to the next member in the list. It only, well, for this simple form of a linked list, it only has one reference going forward to the next, but not necessarily one that points backwards. There are doubly linked lists that can do that, but that's not what I've made here. So in my example, kind of the point of this here is that I'll be able to build on this and then eventually apply this to a game that I'm working on. And that game is something that I also have been streaming in the same playlist called Advanced Cheese Maze, which is a little mouse maze game. So yeah, I think that's pretty much the review. I will make sure that by the end of this stream, or by the time this stream is finished and I get ready to publish the final version of this little practice repo, I'll include this graphic so that you can have this for your own use. Linked lists are super important, especially if you have coding interviews. If you want to get a job at any of the FANG companies, I think they're called Manga now. You know, the top companies basically. I don't know the current acronym. But if you want to get a job at any of those companies, any like of the larger tech forward companies that hire engineers, linked lists is oftentimes one of the things that they may test you for, just to know that you have a basic grasp of the concept. And if linked lists and algorithms aren't really your thing, you can definitely still get work. But there's just certain types of software engineering that definitely requires you know this in order to solve the types of problems that are meaningful in those areas. So enough of this. I'm going to go ahead and jump back into what I was doing previously. And yeah, we're going to like see where we were. So I made a to-do list last time because I knew I would forget. Um, the first thing I wanted to do was review the reversal algorithm because I got it working yesterday and I think I understood what was happening, but it also felt a little grainy for me. So I just wanted to like spend a moment kind of talking out loud and brainstorming what I think might be going on here. So first, I'm just going to actually run my code. Okay, cool. And to run this, it's go run src. And then this last part here is the console log for this reverse method. This reverse method is bound to the linked list construct, which is essentially a class in GoLang. So what I have here is I would be receiving a reference to a list, a pointer rather. And what I'll be doing here is I'll be storing the previous and the next, or I'll have a variable that stores the previous and the next, and this will be of a type pointer to a node because linked lists contain nodes. So the first thing I do is I'm going to, every time this linked list is in this reversal algorithm, the first thing I need to do is start off with the head. So the head in my diagram, you can ignore the blue and purple one. Let's just focus on the green and red ones. So the head is this right here. So that's the first thing. I need to store that in a variable. And in fact, prev, next, and current are all just placeholder or not placeholders. They're basically temporary holding places for things that are going to get shuffled around as this reversal method works. So I'm going to store the head in my current. Okay. So, and I feel like I need to just eventually draw this out. Okay, so head gets stored in current. And then I have a loop, and this loop is going to keep going until I reach the end of my list. So let's just think about this step by step in the most literal sense. So the first time, um, the first time this loop runs, I need to see what the next node is. And I'm going to store that next one because the next one here is node 2. And in order to reverse this, node 2 needs to go on the other side. So actually, let me go ahead and I'm just going to actually try to work this out in my whiteboard here because I am a visual person. In fact, we are all sort of biased towards visual understanding. So let's not even kid myself here. So I'm just going to copy this here, and I'm going to copy this and this. In fact, I should probably group these together. Okay. And then we need node 2. I think you can use, oh, there's no shortcut. Okay. Oops. Let's go ahead and lock you down. Group. And then group. Okay, so the first thing is first. I'm going to take this. In the first stage, I'm going to take this. Actually, you know what? I think this would be really clever if I actually just organize a diagram of each step of this loop. So let's just call this loop iteration number 1. I'm getting really excited right now. I love stuff like this. Okay. So in loop iteration 1, starting out. Okay, we have to start out. So starting out outside of the loop, this is going to be current. So we'll just put current equals original head. Okay. And so in this first version of the loop, next equals current dot next, which is this one here. So we'll say current is here, or next, I'm sorry. Next is here relative to the current head. Current dot next. I don't like how this automatically capitalizes. That bothers me. Oh wait, no, it's just next. It's just next. We have a placeholder for next. And then we say current dot next equals previous. Okay. Current dot next equals prev. And originally, when this first gets assigned to previous, previous is going to be null because I know that because when I look here, or nil, not null, I can see here that current.next and also previous are nil. But we're creating the association because eventually we're going to change previous. So I'm not sure where to put this in my little diagram, so I'm just going to put it below. So it's going to happen like somewhere right here if this was a timeline. Okay. And then current.next is previous. And then previous is going to equal current. So I can put that like right here. Oops. Okay. Make that lowercase. These should all be lowercase. I'm such a stickler over the fact that it tries to capitalize these. I know it's trying to help me have good grammar and all of that. Okay, so previous equals current. And then current is going to equal next. Okay, so current.next in the context of this is going to mean node number 2. Okay. And then when previous equals current, that means that previous will equal node dot node 1. Oops, I can't do that here. So node number 1. And then current, there you go. And then current will become node number 2. Wait, I'm getting something mixed up here. Oh, no, no, no. This will be nil. This will originally be nil, like this. So originally current.next, which is it's the pointer of, we're basically saying, hey, node number 1, we're going to erase your pointer, set it to nil, or set it to this previous thing, but it's going to be nil at first. And then we're going to say, hey, previous, now your new value is going to be, no, let me reverse. So this current.next here, this is a reference to, let me get some arrows going on here. This is a reference to this next right here. Let's make that green. And when we say previous equals current, what we're saying is that this pointer here is going to refer back to this right here. Ooh, how do I do that? Maybe I just put this here like this. like that. Okay, so yes, so these are pointing to the same thing. I guess some image. Okay, perfect. Okay, so this is going to be, um, and actually it will be at this point when that happens, and it'll actually be, I don't think this is the best way to depict this. Maybe I should depict this relationship by steps. So at this point, um, gosh, visual description of this is really hard. I guess that's why it's hard to learn. I think animation just makes so much more sense, to be honest. Okay, so initially we say, hey, node number two, you're the dot next of this head, which is the first current. We're going to take away your pointer and we're going to just make it nil. And then we're going to point your pointer to what came before you, which is current. And then we're going to say, hey, current, now you are this thing by the end of the loop. So I can actually just go ahead and include this in the loop. It effectively is part of the loop since the loop mutates it. So the next iteration of this loop is going to be, come on, line me up. Give me straight. There we go. Oh, 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 there we go. Okay, so now when the loop happens again, current will be node number two. And two will point, uh, and node one will be over here somewhere. The loop won't be concerned with it anymore. So it'll be like done with basically. And this next here, um, this next here will point to it. So I could put an arrow like this. This next here will point to this. And then, so node 2 dot next will now be set. Okay, this will be node 3. This will be node 4. And I can get rid of this. Okay. Okay, so now this next loop, this is iteration number 2. And we're going to say, hey, node number 2, you're now the current. And we're going to start off by making your dot next, instead of it referring to node 3, we're going to make it nil. That's this step right here. And then we're going to I'm sorry, we're going to look at node number 3. We're going to make node number three's pointer for next nil, and then we're going to point it to 2. Yeah, that's what we're gonna do. So I guess I could do this. I guess this could be like, that's kind of the point, is we're gonna be reversing these one at a time. We're gonna keep track of what we're working on. We're gonna reverse it. We're gonna move forward, do the next one. So we're gonna set current.next to previous, which is nil. We're going to say previous, you're now current, which is node 2. Um, node 3, 3 dot next. Okay, this is making a little bit more sense. Okay, so this is step 1, this is step 2, and this is step 3. Well, really, this is step 1 assignment, but that's fine. Okay, so now in this one, we're going to set current.next, which is going to be node three's pointer to its next node. We're going to set that to nil, and then we're going to set it to point to the current, which is 2. And then we're going to say, um, and now that this is basically saving the new relationship, and then this here is moving on to the next one so that the loop can start again. Let me just go ahead and move these over. Ooh, why is this connected? Ungroup. Ungroup. Getting a little too precocious. Baby child. Okay. Um, yeah, this is looking a little bit more sensical. Um, move this over here and put this right here. I really get into these diagrams. I don't know what it is about a diagram. It just drives me crazy. It just drives me crazy. Ooh. And I don't even like feel like I'm critical about it. It's not even critical to me to look at like diagrams that others make. It's just literally making them myself that just like makes me go, ah, ah, no. I really get into it. I could like sit here and just like move around these little arrows all night, all night. Go to work tomorrow, be like, why do you look tired? I've been moving arrows all the live long night. Today sure did drain me. Okay, so I think we got this. Okay, so on iteration number 3, let's just do this again. One thing about me, I'm gonna finish my diagram. Okay, so in iteration 3, now the current is going to be node number 3. So I can move this over here. Boom, bap, shabop bop. Oh, I gotta get rid of this thing that says original head. I don't need that part anymore. Okay, now, yep. So the new current is going to be um, number 3. Next is going to be 4, like this. 3 is already referring to 2, like this, and 4 will now refer to 3 in this next loop. Y'all, this is so much easier to understand now that I took a day break or whatever. I did kind of watch a video over lunch, just a little bit. I didn't watch the whole thing, but I think honestly, just taking some space and letting my brain just kind of like think about other things really helped a lot. Sometimes we like hit our head against the wall thinking that we're going to get through it, and that's just not how it works. Sometimes you just have to wait and take a break. Let your brain rest. Your brain will do the work for you sometimes. As long as you prime it, let's see what I did there. As long as you prime it with the right things, your brain will do a lot of the work for you. You just have to trust it. So, coming back to this, it's definitely significantly easier to understand what's going on. And also, I think a huge part of learning, by the way, is like the emotional stuff. Your emotions determine how well you can access your mental capacity. And when you're frustrated or when something is like confusing, it can cause all sorts of like consequences that affect your ability to like remember and receive information. So just thought I'd say that. Okay, let's make some updates here. This should now be the current next will be node 4. It'll have its pointer set to nil. And then the previous will it'll be replaced with the reference to node number 3, and current will equal I'm sorry, node number 3. Wait. Node number 4 dot next will be nil because it's previous, and then it'll be set to current, which is a reference to 3, and then current will become this here. Current, previous is current. Okay, and then current becomes next. Um, oh, so this right here needs to say 3. Oops. Yeah, current becomes next. So, and then at the end of the loop, once this is done, we will have inverted um, I need to have some way to signify that is there like a reverse um, circle? Oh, wait, that's what I need. I need a circular. I think maybe this could be a good communication graphic for this scenario. Let's make this, I like this color blue. Um, so what this is going to signify for me is just a change in the direction of this list pointers. Um, Here, like this. So 3 is still pointing to 4. And maybe I'll make the ones that change, that signify the change, maybe I'll make them that blue color. Okay. And this means that the pointer has changed from, so let's make a note above this. Um, next, add next changes from node 1 to node, or I'm sorry, from node 3 to node 1. Oh, that is so hard to read. I don't think I enjoy the way the colors have been chosen for this. Well, it's just not text friendly, but it's fine. It's fine. So that's what this signifies here. And let me see if I can draw a little arrow action going on there. Oops. I want this one. And let's also make that blue. Yeah, I like this. Okay, so here, same thing. Um, let's say current dot next. And let's make this size 14. I'm actually kind of surprised that I'm spending this much time doing this whiteboard thing because it makes sense that I need to do this for my understanding, but I didn't really plan that this was going to be like a thing tonight. So, but that's how it goes, you know? That's the journey. That's the journey. Okay, so in this context, the pointer, so dot next changes from 4 to 2 to node number 2. Okay, and then lastly, in this last example here, the current, it changes. There was no pointer, so it changes from nil to 3 in this last iteration here. This is going to make a very interesting visual graphic just because I'm going to have to like, I should just go ahead and make this line up because this is going to be really hard to put all in one image and save and make it accessible and easy to read. Um, yeah, it's going to be very tall and very small unless I compress this quite a bit. I'm going to have to come back. If you haven't noticed, by the way, like whenever I put up graphics to actually share in a more long-term format, like in my repos, I will generally go back and rework them because the graphics I make in the stream, um, it's not that they're like incorrect. It's just that without commentary, it would be hard to know like the context of what they're trying to communicate. And there may actually be some inaccuracies in there. And without the context, those inaccuracies um, to me are just more problematic. So that's just to say that I'm not gonna spend much more time on this now, but I feel like this visual makes more sense of what's going on in this reverse um, method here. Yeah, so we're just going through step by step, layer by layer, and we're just changing these references so that they're going in the opposite directions. And I think if I just make a couple more changes, let me just update these. colors here on these arrows. Um, so 2 changes to 1, 3 changes to 2, 4 doesn't have a reference outside. Okay, so in fact, if I make these green, I feel like that makes more sense because that is the color of the next. The nexus is the next die. I don't know what the plural version of that is. One thing I'm really big on is like making sure that the visual indicators like make sense. Visual cues. That's like a huge part of making an infographic is like using colors and design so that people don't have to do as much struggling when it comes to understanding what you're communicating here. If you use colors and visual hierarchy well enough, people can have something closer to an intuitive understanding of what you're trying to say. So that's kind of the goal for me. Um, oh, almost forgot this. This is the node 1 is the first current. So you can see it starts off. Actually, let me go ahead and just put that um, up here like this. I'm not sure if I need this one outside because I'm really just concerned with what's happening in the loop. So there you go. Okay. Okay. Cool. So by the end of all this, this will have been reversed. It's like a little wave. It's like a little wave. The wave passes along. And then by the time it gets to 4, there's nothing after 4. So 4 is 4 just becomes the new head. Oh, I should do that too. So when we break outside of the loop, we need a line here that represents the return. Or it's not a return, it's just a break out of the loop. So current um, current well, when current is so this loop only happens when current is not nil and current tries to get set to next. And when it's 4's turn in the loop, so there actually would be another iteration here. And after that, I'm just going to type, I'm not going to do another graphic, but there would be during loop iteration number 4, node number 4 does not have a or code node number 4's next, which is current dot next, is nil. Oh, actually, this happens at the end of the third loop, actually. No, no, no. This happens in the fourth loop. It's just that the fourth loop doesn't do anything. With all these values are going to be nil. And at the so in the fourth loop or the fourth iteration of this loop, oops, um, current.next, which is four's next, will be nil. And so as a result, this is way too small for y'all to read. Let me make this bigger. So as a result, the loop ends and the new head of the list is node number 4 at the time of um, so there is no fourth loop, but it does come back around for a fourth time. It just can't get into the loop scope because by the time it comes back for that fourth time. So when so during the attempt to start the to start loop iteration number 4, node 4 is next is nil. As a result, the loop cannot continue. And the new head, so um, this break, um, this this will move on to the next code, which will set the new head of the list to node number 4. Okay, that's what we need. Okay, cool. Um, I'm feeling like, well, I'm feeling good about this, first of all. I'm also feeling like maybe, oops, I'm feeling like maybe I need to do a review of this. I would hate to do, well, not hate, but I kind of don't want to do like another stream on this because I was kind of just planning on finishing this today and just being done with it. But I do feel like this might warrant me to come back and do a final just overview of like in a more concise form. I might not do it immediately, but I feel like at some point in the future, doing a cleaner review of this and also like the linked list thing might be a good idea. And that would make for some good standalone content, I would say. So, yeah, don't quote me on that, but that's kind of where my thoughts are right now. My other thought is that it's been 49 minutes, and so it might also be time for a short break. I'm just going to make a few small adjustments to this because I am being very neurotic right now. And then I'm going to take a break. So um, let's put a box around this square. Yeah, there we go. I'm kind of digging this software, Freeform. It's not bad. It's not great, but it's like, it's okay to actually just use. You know what I'm saying? If it was any worse, I might not be into it. But as it stands, it's side. You know what I'm saying? It's side enough. It's side enough. Okay. Actually, these need to be gray. I'd rather not do that color. The color blue. Blue's been used enough. Okay. And let's go ahead and put a little header here too. Say loop 4. We call this loop break. Okay, cool. Yes. Yes. Let's just line this up here. And then we need to put like just a nice little header on top of all this. right here. Oops. And this will say linked list reverse and 48. Okay, so I think I'm good on this part right now. So I'm going to take myself a little break. Ooh, hot chocolate sounds really good. Haven't had that in a week or so, so that sounds really great. I'm gonna go make me a little cup of hot chocolate. You should do the same thing actually. If you've been sitting for a while, get up, stretch your legs, get you a nice warm beverage, and then meet me back here in about 10 minutes or so. If you're watching this video in the future, do not skimp on your breaks, okay? Breaks is like one of the best things in life, okay? Your body will appreciate it. Go take a break and come back here in 10 minutes. You'll hear me talking, so you don't even need to watch the screen, okay? So right now it just turned 1 a.m. I'll be back at 1:10. Yo, what's up? What's good? What's Gucci? What's poppin'? Okay, I got me some hot chocolate here, and also I have a confession to make. I was wrong. I was wrong about everything. Basically, I stand by my work, but also I have to admit that I have made a grave error in my current depiction of what's occurring during this reversal method algorithm thing. Let's take a look. Um, this might end up turning into just me working on this for the rest of this stream. I don't know. We're going to see. But you know what? I'm going to get it right because that's the point. So let's take a look. Okay. So, yuck, yuck, yuck. Okay. So, when I was looking at this, something felt off to me while I was waiting for my water to boil. And I realized that the beginning of my loop, I actually am depicting, this is actually depicting loop number 2. Um, what's going on here? So there actually is something that happens before this part here. And I think I need to just add to the top. So I'm not going to destroy this, but I am going to move it so I can expand it at the top. And then what I'm going to do is I'm going to just re-talk through it and make sure that once I edit the stuff at the top, then I can confirm that the stuff beneath is also okay. I'm going to have to make some tweaks as I go. So what I realized is that during the first iteration of this loop, the first thing that happens is that the reference for current.next, which is this here, this one right here, this is just set to nil. This becomes nil. Which is, so here, this just becomes nil. And previous equals current, which is node 1, and then current equals next, which is number 2. This part does not mean anything at this point. So this reversal thing here, this is actually happening, oops, at this point right here. And I could probably flip these. So current.next changes from node 2 to nil. I was being a little dramatic when I was like confessing, by the way. It's all right. I'm a little dramatic. You know what I'm saying? I'm willing to admit that. That's what makes me great. That's what gives me the extra little flavor. Watch me put this almond in my hot chocolate. Oh my God, that's the best thing I've ever done. All day, every day, for real. Okay. Um. So. So yes. So what's happening here is we're just basically shuffling around some things. We're going to put this here, put this over here. So loop iteration number 1, next becomes, I'm sorry, node 1's next becomes nil because it is no longer going to be pointing to anything here. It's no longer going to be pointing to anything because it's going to be the new end. Maybe I should note that as well. node 1 will become the new tail, so it doesn't need its next to point to any node. Okay. So that's what's happening there. Let's go ahead and just boost that on up. Give it a little boost. And we can go ahead and make you italicized and 14. And put a little star. Node 1 will become the new tail. So it does not need to node 1's, yeah, so it does not need its next to point to any node. Okay, so it's going to sever this connection here, and it's just going to float off, and we're going to say that this is the new previous, and the new current at the end of this loop is going to be node number 2. Okay, so I'm going to have to adjust this here. The new current is going to be node number 2 here. In fact, let me go ahead and get this popping. Like that. And when node number 2 is the new current, which is here, then we will set node number 2 next to node 1. Because remember, at this time, current.next is going to mean previous, which is this right here, which is node number 1. And this will sever this connection right here. Maybe I should make that into a gray arrow without, yeah, I just make that into gray. That would just represent you're dead to me. You're gone. You don't exist. We're no longer cool. Okay. So that's what that's going to mean. This has been severed. So current dot next. Let me go ahead and put this down here like that. I'm definitely going to have to come back and like gridify this. I just know this is going to drive me crazy. It's going to drive me crazy. Okay. So this goes there. This goes here. Like that. This can go right here. Okay, I think we're getting somewhere. Oops. Do I need to move my drink? Press spill on my keyboard. Okay. So in this next loop, we're severing this connection and we're saying, hey, node 2, now point to node number 1. And this arrow needs to be the other way around. So we're severing this connection and we're now pointing 2 to 1. The previous will become node number 2, and then the current will become next, which is node number 3. Let's make next bold because we're gonna overlook that if we don't do it. So there we go. Okay, so that's good now. Okay, so now we have these two. Now we have now we have this pointing, and current is going to move. Node number 2 is going to be over here in the safe space. We're done with you, boo. You good. Let's ungroup, please. Nope. We got to use this thing down here. And we're going to go like that. There we go. So this needs to be light blue. Yeah, I'm not even gonna rush this, honestly. I feel myself just wanting to be like, I just gotta get this done. But you know what? We're gonna savor this learning experience and we're not gonna rush. Because if I can get this working, I know that my understanding is going to be all the better and I will appreciate this effort. And also, I know that someone out there is going to appreciate this graphic when I finish it as well. This is not a distraction from the learning process. This is the learning process. Okay, that's the mindset that we're cultivating over here. I don't know what y'all do where y'all from, but that's how we do it over here. Take our time. We don't rush. We take our time and we're consistent so we don't have to rush. But y'all don't know nothing about that, do y'all? Yes, y'all do. Yeah, you do. I know you did. I'm just testing. I'm just asking to make sure you do. See me looking out for you. See how I look out for y'all, my best friends. We basically cousins. Okay, so in this next iteration, let me just change my numbers here too. So this is iteration 2, and this is iteration 3. Okay, and I'm trying to change these colors here to represent. Let me make these gray. I feel like the old pointers need to be gray. Oops. This is getting real detailed. I better get like a Grammy for this. Can I get an award or something? An Emmy, Oscar. Okay. So iteration number 3 now. The third time we come in here, current is going to equal node number 3. And that will go here. And we can make this blue. And this one will be gray. Okay. This line could be dotted, and I don't need to have the arrow on it. That's confusing. Yeah, I like that. Maybe I'll make this some other color. Let's just make this all green. No, purple's fine. Purple it is. Purple it is. Okay, so now current is 3. Next is node 4. And we have severed the connection between 3 and 4, so that 3 faces 2. So this can go here, this can go down here, this will go under here. Bow. Either you bow or you owl. Oops. Oopsie daisy. Okay, so now we have changed the pointer for 3. So current dot next is this one. Current dot next. I'm missing something here. What am I missing? Oh, current dot next is now node number 2. Current dot next is node number 2 here. So I can go right there. And then previous is equal to current, which is node number 3. Italics. Italics in the building. Getting real serious business. And then current equals next, and next is node number 4. Yes. Current, previous, current. Maybe these should go like here, like this. Yeah, I like the way that looks. I like that a lot, actually. Let's move this here. I'm not sure I'm digging the way that alignment works in this app. It's like not terrible, but it's not what I need. It's not what I want. That's what I mean to say. The need part, it works, but it's not like, it's a 5 out of 10, which is like, it's all right. It's not great, but it's all right. Okay. And this needs to be blue. Or black. Not blue, black. It needs to be black. Okay. And let me go ahead and adjust these too while I'm at it. Okay. So sever this, flip it to 1, and then this is pointing over here. And then at the end of this loop, previous becomes current, and current becomes next. Bold. Oh, okay. Okay, I think we're getting somewhere here. I think we're getting somewhere here today in this location. Somewhere around about over here. Okay, so node okay becomes number four, and then this loop will try to run again. Um, it'll go again because current will have a value after loop number three. Okay, this is the part where at the end of my before my break last time I was like not really getting it. At loop number four, it's still going to do its thing. In fact, I could just copy all of this, put it down here like this. And there is no, okay, so at the beginning of here, current is going to change. Um, there we go. So here, current is going to oops, change so that it is number four, like this. And now number four will point to number three, like that. This is now current, and current.next is going to be nil. Current.next is going to be pre. Wait, what did I do? How did I get? Oh, it's going to be pre. So node 4 dot next is going to be node 3. That's what I meant. Next is going to be current dot next. So I need like a different symbol now. I need like a little like a no symbol, and X. Yeah. Let's make that orange. And yeah. And make that orange too. So current.next from 4, number 4 doesn't exist. It will be nil. And let's also make this, let's get rid of this line here and just make this orange. Okay, I think I need to compress some of this so it'll fit. And this could be orange as well. And at the end of all this, previous.next equals current, which is node number 4. And current equals next, which is nil. There we go. Oh yeah. Oh yeah. Mm-hmm. I sure did that. You can't tell me nothing. I sure did that for sure. Bold. Bold. I'm just gonna bold anything that is supposed to be a variable in this context. And bold. Okay. And maybe I put the word next under the X like this so I could, oops, so I could save some space here. And let's go ahead and make you 18 like that. Current.next for node number 4 doesn't exist, so it will be nil. It will become nil. Let's make you 18 as well. Let's make you 18 as well. And let's also make you, oh, you're already 18. Cool. Okay, cool. And so the loop will break because during the attempt to start loop iteration number 5, node 4 is next, which is this here. Our current, which is node 4 is next. Is nil. So as a result, the loop will break. This will move on to the next code, which will set the new head to of the list to previous, which is node 4. Let me break this off and do that. Like that. There we go. So this is our visual description. I am so proud of this. Let me just say, Picasso, Da Vinci, Michelangelo. Mm-hmm. That's how you do it. That right there, This right here, all of that. That's how you do it right there. If you don't know, now you do. And if this is wrong, I'm gonna feel very crutchy, but it's fine. It's fine. I don't have to be perfect, okay? But for now, I'm going to celebrate this. And also, I am just feeling grateful that I had the epiphany to realize that what I had before was wrong. I would rather that. I'd rather that and then actually come back and fix it than to just not know and to live in ignorance. And this still could be wrong. Fresh eyes will tell me. So will social media. So, yeah, I'm gonna end up. I'm just gonna post this probably tomorrow. I have a plan that I'm gonna turn basically this into some type of written content. I have a dead blog, and I've been trying to post articles on LinkedIn. So this is gonna become something else. I will have another chance to revisit this, and also making another video for the stream is something I will do as well. So I think I get this. I feel a lot more confident now than I did last time I talked through this. So let's just do a little cleanup here. And then I think I can. I think I actually might be ready to hop off the stream here in a second, to be honest. It's Friday. It's 1:41 a.m. I only really want to do these streams for like 2 hours. I might actually just finish. Was there anything else here I needed to do? I got the delete. Let me check my plan real quick, actually. So I got add to start, add to end, delete with the value, or delete with value. This will only ever delete one, whatever the first one is, whether it's at the head or something else. Oh, okay, so this one is done. For some reason, I was thinking this wasn't done. It is, but I had a stretch goal. I'm not going to do the stretch goal until the very end because it's just not the plan, but it is definitely a worthy challenge to make a new delete method that will get rid of all values in the node list. I think the value of this exercise would be because I don't have it in my plan, it would just really press me to like conjure up a solution of my own, which I think would be very useful. But I'm going to treat that like a whole nother vibe. It's not going to be part of the series. Um, so the next thing I need to do, okay, how about this? I'll make you this deal. Let's do a little bit of cleanup here, and then I will lay out the plan for the doubly linked list file. And then that'll set me up to be able to just come back in the next stream, knock that out, and then we'll be done with this little linked list series. And then somewhere in the midst of all of that, I will try to like come up with a game plan for how to make like a review video that can just be a standalone piece of content, because I do think that these graphics are really useful and helpful, not just in making them, but also for the next person. I could see how they would be very useful. Ooh, I messed up my first thing over here. Let me fix this. I almost didn't even notice this. Ooh, while I'm over here, let me go ahead and fix this up too. You see how I just really be getting into this? Like something about making these little diagrams just really shakes me. Ooh, my cookie fell off. I got a little too excited there. This happens a lot. This is my life. It's my life. Let's make this one. I actually just want to have this. Okay. There you go. Fixed. Done. Bingo. Okay, so a little cleanup. I think all of this could just go right here. Let's get my arrows fixed up. Yeah, get my arrows fixed up. I don't like how the arrows here, um, like right here, are not related to this because these are grouped, so the arrows are being drawn with the center at the middle of the group shape as opposed to the rectangle shape. And that's like kind of killing my vibe just a little bit. So we're gonna have to fix that. There we go. Oops. There we go. And ungroup. Next time I will know better. Just use the built-in arrow. I don't even know what it's called. What's it called? Connectors. I'll just use the built-in connectors. I was being kind of belligerent. Okay, I'm so excited. I might even post this tonight. I might just post it and ask for feedback. And then next time next time I'll write an article or something. I'm tempted to talk through this again, but at the same time, I will be here all night. I might have time. I have time. Okay, so I'm gonna do this, and then I'm gonna now just come through here. What's in my diff? Okay, oops, that's a message. So update advanced comments to remove to-dos. And then I said that I was just going to lay out or like get this like basically started so I could jump in real quick next time. So we need to import doubly linked from doubly um oops, there we go. Let's go ahead and run that and make sure that runs. Oh, we need to comment this out too. Okay, that works. Um, for the doubly linked list, we need to do all the basic stuff that we did in the other ones. So we need to create node struct. We need to create doubly linked list struct, and this will have fields FIELD. I prefer E except after C. Of head and tail. So doubly linked lists will have a reference going in both directions, which I think would mean that a reversal would be even more complicated. Oh my goodness. I can't even imagine how to do a reversal on a doubly linked list. Yeah, I don't even know. I mean, I don't even know, honestly. Okay, that's another problem for later. Um, so create double list, linked list struct, and then we need to create add to start method. And these need to be to-dos. I need to just to do. So we need to create add to end method. We need a way to display this. Create display method or doubly linked list. I always tell my students, like, just write your comments out. It's just a part of the planning process. Eventually, you won't even have to do a lot of the whiteboarding stuff. You may, if that works for you, but if you just write out good comments and just think through things here before you start writing code, you'll save yourself a lot of time. You will. Absolutely. I probably cannot name my function doubly linked list. In fact, let me just refactor these real quick and just call all these functions linked list. Oh wait, no, this one has to be called basic linked list. Well, I'll just do it for the doubly. I'm just running into like a naming issue because it's called doubly linked list here, and I have this function called doubly linked list, so it just needs to be like this. Yeah, it's just gonna keep me from running into issues, I guess. Oh, okay. So create display for doubly linked list. Ooh, excuse me. And then lastly, the to do is create display reverse. Not sure what this does, but I have it in my notes. So we're going to do it. Create display reverse method or doubly linked list. Okay. And then we're going to have stuff going on here inside of the main function for this module. So yeah, I should probably indicate. So for add to start, anytime we're like adding, we need to have the data that we are storing. So data, and that will be int for add to start. Same thing for add to end data, type int. Display doesn't need anything. Display reverse also doesn't need anything. Okay. So I think this is the game plan. I'm just going to stick with that for now. Assumptions can be wrong. So update doubly linked list with to do outline and comments. Cool beans. Okay, so before I get off of here, I'm going to talk through this just one more time. And I have like 15 minutes, so it's no rush. I am just so committed to doing 2 hours of streaming whenever I get on here. I don't know why. It just does not feel satisfying to me to not do 2 hours. I can't explain it. Okay, so here's the actual code for this reverse method. I should just call it algorithm. And here are the directions here, or the description. I didn't really want to lean on this too much, but So here's the actual code here. So what this code is saying to me is that the first time this loop happens, node number one's dot next is originally pointing to node number two. The first thing we do is we say, what is the next thing that comes after number one? Just to be clear and to save that somewhere. And then we say, hey, node number one, your next is going to be this thing called previous, but there was no previous before you. So node number one, your next is going to be nil, which is convenient because you're also going to be the tail and you would have no next. Okay, so that's why it's going to be nil. And then we say, hey, yeah, so it's nil. And then we say here, okay, now that that has happened, the previous is going to be the current, which is node number one, will be considered the new previous, and the current will be the next, and the next will be node number two. Then that loop is done. So as a result, one is not pointing to anything, and then we start the next loop. And the next loop, number two is the new current, and the next is going to be considered node number three. We're going to just say, hey, three, we're going to save you, but number two's pointer is going to be set to the previous, which will be node number one. Node one.next is nil. Yeah, that's right. So we're going to sever this here. I should make this facing the other way and make it gray. Okay, cool. So in loop number two, current is going to be set to node number two. Current.next is going to be previous, which is going to make 2 point towards 1 now. And then the next is 3. We're holding on to that. And then at the end of all this, the previous is going to be the current. So this will be considered the old thing. And then the next will be, or current will be this one here. So at the beginning of this next loop, current is 3, just like it was set here. Current.next is going to be previous, and previous will have been 2. So node 3.next is node number 2. Number 4 will be next, because next is current.next as of this line right here. Wait. Yeah, as of this line right here. And then at the end of all of this, current.next changes. Okay. I feel like this shape should be like here. Actually, this needs to be like an X. I'm going to wait. I'm going to do that at the end. Okay, so current becomes 3. Previous becomes 3. Current becomes next, which is node number 4, which moves us here. Current is 4. Current.next is the previous, which is the 3. There is no next, so, or there is a next, but the next is nil because 4 will not have anything to point to. Or 4 was never pointing to anything, rather. So previous becomes the current, which is 4, and then current becomes next, which is nil. And then when 5 comes around, when it comes around for the 5th iteration, It cannot do it because current is going to be nil at that point, and then it'll break out of the loop and it'll set the head to previous, and the previous will have been set to 4, which will essentially have reversed the entire data structure. So, okay, that's cool. That checks out. I'm going to go ahead and just replace these little refresh things with X's. They should be X's. I feel like that makes more sense. It's like saying, nope, not over here, buddy. Not over here, bucko. Let's go ahead and put let's make these gray. I just wish there were more colors in the world. I've actually felt that way for a very long time, but it's okay. That's how it be. Let's make these X's purple. Okay, so that's been severed. And get rid of that. This can go here. And let's update this. And then this is good. Oh, this needs to be orange. No. This needs to be blue. Okay. That line we don't need. So we should fix this up here. So current.next for, let's actually write in our completing list here. At the beginning of the loop, current.next for node number 4 was never pointing at anything. So next will become nil. And let's just do a little arrow here. Excuse me. Okay, so yeah, that looks much better. Much better. Okay, so what else? Do we need to do anything else? Ooh, we can refresh this. Okay, so I think we're pretty good. think we're pretty good. Um, Maybe I'll just throw up some little dividers here. Yeah, that looks nice. Oh, you know what? I should probably go ahead and, gosh, I thought there was a way. No, I thought there was a way to like export this easily. Um, it's going to be kind of annoying, but I think I actually need to break this up into multiple images. Yeah, I don't know if there's like a convenient way for me to do this. Well, let me start off by just taking this and making it into its own thing. Um, yeah, let's make it into its own thing. Okay, that worked. And that way, I think I can actually later on export this as a PDF and yeah, I'll be able to export this as a PDF and it'll try to maintain this. I feel like a PDF would be a better way to share this because then people could zoom in and it won't be like grainy and all weird looking. So, okay. So that's that. That's the stream. That's what we had did. This went in a little bit different direction than I thought. I was originally just planning on getting on here and just coding it up and being done, you know, being done and being out of here. But I'm glad I did this. I think that I will look back on this experience and be super happy. So, words of wisdom. Where's the wisdom? What should I say? Um, do not underestimate all the different elements of your process. This is something I'm telling myself because I need to remember this as well. And I think tonight was a good demonstration of that. So, a lot of times when it comes to learning, trying to grow in general, a lot of times we put so much of the emphasis on pushing forward, right? I got to push forward. I got to knock this wall down. I have to break through this door. I have to push past some thresholds. A lot of times, learning and growth comes off as this very like extroverted, active thing. And that is a huge part of it because growth and learning do require effort, and effort takes energy, takes willpower, takes all those things. But when I say like don't underestimate, don't don't misvalue the other elements that are involved in all of that. What I'm saying is like sometimes taking a break, sometimes being still, sometimes giving yourself the ability to disconnect, sometimes creating a vacuum, right? Sometimes doing those other things is just as important as the active aspect of learning and growth. You really need both. And that's called having balance. When you spend your learning and growth journey being so aggressively just relentless, like you will definitely get somewhere, but it's not necessarily going to get you there faster or more effectively. And a lot of that comes down to like this need to control. And it's rooted in anxiety and insecurity rather than the kind of feelings and self nurturing that I know you deserve, that we all deserve as learners. I've been in this situation. I've been a lifelong learner. I've been through so much schooling. And what I really learned from going through a master's degree program and then going back to coding boot camp and taking just so many workshops and certifications, what I learned is that sustainability, emotional safety, the ability to feel relaxed and comfortable in the process is not just as valuable, but sometimes it's more valuable than that relentless, fiery energy of just like, rah, you know? And if you can get to the place where you can just calmly confront blockers and challenges and actually breathe through it and just have a sense of trust, like, hey, I don't have it now, but I will. I don't understand it now, but I will. This isn't working at the moment. It will. You know, all I have to do is just show up. I show up, I put in the effort, I make sure that I'm doing my part, and then the other, the universe, my brain, my mind, all those things, they're going to show up for me as well. And then I don't have to be stressed or worried. Then taking a few moments to go sit down and relax, or to go meditate, to go make a cup of coffee or hot chocolate, doesn't feel like I'm doing a disservice, because that is a part of the process. That's a part of the process that creates the balance. And in those moments, you get inspiration, you get ideas. Sometimes you don't, but more than oftentimes, if you treat yourself and your learning process with respect and reverence, that learning process itself is going to bless you with inspiration, motivation, answers, dreams, those kinds of things. And this is something that I very, very clearly have noticed in a lot of my heroes when they talk about their process for how they're able to do like innovations and come up with great solutions. That it's not just about the active control that we oftentimes want to have as people, you know? So trust yourself, trust the process, trust the universe. Those are all mechanics that are at play when it comes to your growth and learning. And you can do amazing things, you know? So with that being said, thank you for coming to another OpenPair session with me. I hope you enjoyed this, being vulnerable with you is always a joy for me. And stay tuned. I guess we're doing a part 3 for this linked list thing. When is this going to end? That's actually a quite clever reference to how linked list works, because the point of a linked list is that you don't actually know how long it is. All you can do is just traverse it until you get to a node that does not have a pointer. So I don't know. This series, this little micro series, I guess is a linked list in and of itself. And we'll node by the next stream whether or not there is more to do here. Okay? So, yeah, I'll catch you in the next stream. Thank you for coming by. My name is Key. This is Made of Development, and this stream is called OpenPair. I'll catch you later. Bye.